All right, so let's talk about proportions. What is a proportion, ladies? A proportion is an equation stating that two ratios are equivalent. So it's a proportion stating that two ratios are equivalent. That's what makes up a proportion. I have one ratio equal to another ratio. And when we were learning about ratios, I told you that one of the most popular ways to write them mathematically is writing them like a fraction. So you can see in this example, I have my first ratio, A over B, is equal to my second ratio, C over D. So here you can see in this example that proportions are similar to equivalent fractions. Proportions are similar to equivalent fractions. Alright, so then the big question is, well, how do we solve a proportion? This little box right here is going to be our guide for how to solve a proportion. To solve a proportion, we must look for the relationship between or within a proportion. So when we're talking about between a proportion, we're talking about across the proportion, from one ratio to another. Across. Between means across. When we're talking about within, we're talking about up and down within the same proportion. Like, is there a relationship from A to B here? Or a relationship between C and D? And then lastly, sometimes we must simplify first. Sometimes you don't see the relationship right off the bat, but if you simplify one of the ratios, that relationship will become clear. And we're going to have examples that talk about all three ways to solve the proportion. All right, so let's open it up. So solving a proportion, we're going to be using predictions. We're going to be making predictions with proportions. So using proportions to make predictions, you will use given ratios and labels to create equivalent ratios. Or to create your proportions. So in every problem example, they're going to give us one complete ratio. We're going to use that ratio along with its labels so that way we can set up our proportion or our two equivalent ratios. So let's look at the first example. At Paul's Pizza, the ratio of the number of cheese pizzas sold to pepperoni pizzas sold is 2 to 7. If there were 18 cheese pizzas sold, how many pepperoni pizzas were sold? So what are the two things we're talking about in this problem? What are we comparing? Cheese pizza and pepperoni. Okay, so I'm going to first write my label. I'm going to write cheese over pepperoni. The good thing about proportions, remember in ratios how order was super important? The good thing about proportions is order is not important. What is important is that my numbers match my labels. So in this label, what is on top? What label is on top, my numerator? Cheese. So that means in all my ratios, my cheese numbers better be on top. My pepperoni numbers better be on bottom. Okay? All right, so the given ratio. The given ratio is right here, 2 to 7. There's my given ratio, but what does that 2 represent? Is that 2 a cheese number or a pepperoni number? You have to go back and read the problem. Yeah, the ratio of cheese sold to pepperoni. So this ratio is important. Cheese comes first, so the 2 is a cheese number. pepperoni. The 7 is a pepperoni number. Now we're going to make an equivalent ratio, so I know another fraction. And here's a really cool thing. One thing that I do to kind of help, I just kind of make a T-box. It kind of helps me in line. Everything on top is going to be a cheese number. Everything on bottom is a pepperoni number. So now, this second ratio is what we're looking for. So they say if there were 18 cheese, so am I going to put 18 on top or on bottom? Where's my cheese numbers? 18 cheese. So cheese is on top, so I'm going to put my 18 on top. So if there were 18 cheese pizzas, they want to know how many pepperoni pizzas. Well, this amount I don't know yet. And if you remember back to equations, when I don't know something, I'm going to put a variable instead of like a question mark. I always just use the letter X. So I'm going to put a variable. So now we have to look at how would we solve that. How could we use that to solve? Well, we go back to that first paragraph at the bottom of the first page. I first need to look across the ratios. So I look across, going from one ratio to the other. Is there a relationship between 2 and 18? Is there a mathematical relationship? 2 times something gives me 18 really easy. What? Not 2 times 4. 9. So I can say to get from 2 to 18, I can say times 9. 2 times 9 is 18. There's my relationship. But as we know, what I do to the top, you do to the bottom. So times 9. Yes, I do need to see all of these steps. I need to see the scale factor that we're multiplying by. We're getting bigger. From 2 to 18 is getting bigger. So I'm multiplying. So 7 times 9, what does that equal? 63. So then how many pepperoni pizzas were sold? 63 pepperoni pizza. 63 pepperonis. All right, let's look at example number 2. The ratio of boys to girls in the 6th grade at Krimmel is 5 to 3. Oop, there's a good ratio right there. And it's a ratio of boys to girls. If there are 45 girls who walk to school, how many boys would you also predict walk to school? All right, so what are we talking about in this problem? What are we comparing? Boys to girls. All right, I'm going to write it just like this. Does it matter which one we put on top? Not in a proportion. In a ratio it does, but not a proportion. So I'm going to make my T-box. All that matters in the proportion is that since I put boys on top, my numerators in each of my ratios need to be boy numbers. Girls are on bottom, so girl numbers have to be my denominators. All right, the first ratio, what was the ratio given? 5 to 3. All right, so which one of those numbers was my boy numbers? 5 was my boy, 3 is my girl number. So now we look for what's missing. If there are 45 girls, so where am I going to put my 45, on top or on bottom? Bottom, because that's a girl number. How many boys? I don't know my boys, so I'm going to put my variable there. All right, let's multiply or divide. First of all, I have to go from 5 to this x right here. So, how does 3 become a 45? 3 times what gives me 45? Three times 15. It's kind of a big number. 3 times 15 gives me 45. So what I do to the bottom? So I got to write my times 15 over here. So now I may have to come over to the side and do some side work, because I need to multiply 5 times 15, or 15 times 5. 5 times 5 is 25. Carry my 2. 7. So x is equal to 75. So what does that 75 mean? 75 what? 75 boys will walk to school. 75 boys will walk to school. So see how we're using those relationships to fill in that missing piece of that fraction? All right, let's look at the next one. All right, example number 3. On a road trip, every 2 hours of driving requires 4 bathroom breaks. How many bathroom breaks would be needed on a 3-hour trip? Every 2 hours of driving, 4 bathroom breaks. There's a complete ratio right there. So what are we comparing? 2 and 4. So 2 represents what? 2 hours. So I might write that as hours to bathroom breaks. I'm just going to abbreviate that and put restroom, RR. You can write out the word bathroom if you like. All right, I'm going to make my proportion box. Helps me keep my numbers straight. So this ratio that we were given, 2 to 4, 2 is what kind of number? Is 2 an hours number or a restroom number? Hours. So where do we put it, on top or on bottom? So 2 goes on top. 4 is bathroom break, so that goes on bottom. Now, what am I going to put on this side? By looking at the rest of my problem, what am I going to put over here? The 3. I'm looking, how many bathroom breaks? So I don't know the bathroom breaks, right? So I can put my variable. How many bathroom breaks on a 3-hour trip? All right, let's look for the relationship. First place we look is where? Across, right? From 2 to 3, is that an easy relationship? 2 times something gives me 3? Okay, so I didn't see a relationship going across. Where was the next place we looked? Up and down, right? Is there a relationship between 2 and 4? If I'm going down, I could say 2 times 4. If I'm going up, I could say 4 divided by 2 gives me 2, right? But let's look over here. I have to start here and I have to find my answer. Going down, so we're going down. So 2, how does the 2 become a 4? What did we do? Times 2. Because 2 times 2 gives me 4. But what I do to one side, you do to the other. So I have to multiply the other side times 2. So 3 times 2, that's going to equal 6. So then my final answer would be what? 6 what? 6 bathroom breaks. That's a lot of breaks for a 3-hour trip, don't you think? Maybe they have a toddler that has to go to the bathroom all the time. All right. Last example. The student council can make 12 jollygrams in 8 minutes. At this rate, how long will it take them to make 9 jollygrams? All right, do we see a complete ratio that they gave us? They gave us both parts. Where? What's my complete ratio? Good. 12 jollygrams in 8 minutes. So again, what are the labels that we're comparing? Jollygrams in minutes. So I'm going to write out my labels. Jollygrams over minutes. All right, let's make my proportion box. So my first ratio, 12 jollygrams in 8 minutes. What am I trying to find out? Which one gets the what?
You goes again.
Okay, I'm recording it so you'll be able to play it back as soon as we're done with this example, okay?
Okay.
All right, so I'm trying to figure out how long will it take. So my variable is going to go down in my minutes because that's what I don't know, how long. How long will it take to make 9 Jolly Grams? All right, let's look for relationships. First place we look. Across. 12 and 9, is that a relationship? 9 times something gives me 12? Nope, that's not a relationship yet. What about 12 and 8? 8 times something can give me 12? Nope. So, I can't go across, I can't go up and down. What was the last thing we have to try? Look back to the first page of our notes. Lastly, what do we need to try? Simplify. So when I simplify, I'm going to look at this 12 and this 8. What number divides both evenly? What could I divide by to simplify? What number goes into 12 that also goes into 8? 2. Is there a bigger one? 4. Right. So I could divide by 4. So in this case, we had to simplify first. And when we simplify, it's going to give us a new set of equivalent ratios. What's 12 divided by 4? So 3 is my new top number. 8 divided by 4 is 2. So there's my new equivalent ratio here, and I'm just going to bring down my 9 and my x. Now can you see a relationship? Where's your relationship that you see? The 3 and the 9, right? Because 3 times 3. So to go over here, I have to do times 3. What I do to the top? Do to the bottom. So times 3. And x is going to equal. So how many Jolly Grams could we make? 6 minutes. Sorry, 9 Jolly Grams in 6 minutes. So remember, the first way we look is which? We look across. If we don't see a relationship, then we look how? Up and down. And lastly, we might need to simplify.